Hey everybody, in today's video we're going to be looking at more complex types of word problems that have to do with related rates involving difficult derivatives. We're given the following situation where the surface area of a sphere is increasing at the rate of 14 pi square meters per hour. At a certain instant, the surface area is 36 pi square meters. What's the rate of change of the sphere's volume at that instant in cubic meters per hour? So as you can see, we want the rate of change of the sphere's volume, so dv over dt. Now, two really helpful formulas that we'll be using is the area of a sphere, the surface area, but we're just going to say area for short, which is 4 pi r squared, and the volume is 4 over 3 pi r cubed. Okay, so we're given dA over dt, which is the rate of change of the surface area, or we're just going to say area for short, respective to time, is 14 pi square meters. And in this specific moment, we're given that the area is 36 pi. And we can plug in the formula of an area, which is 4 pi r squared, and we can solve for r at this instance, which is 3. Now we're going to take the derivative of the area formula and see if we can do anything with that. So we're going to take the derivative with respect to time, and remember 4 pi is a constant, so we can move that aside. And then the derivative of r squared is 2r, and then chain rule, you have to find the derivative of r, which is dr over dt. Now, in this specific moment as well, we know that the radius is 3. So we plug in 3 because that's what we got in the previous equation for r, and we can solve for dr dt. And we're given dr dt equals 7 over 12 after dividing both sides by 24 pi. Now, let's do the same thing with the volume equation and see if we can get any information from there. So we're going to take a derivative of the volume equation with respect to time, and the same thing for the taking derivative of the area equation. As you can see, 4/3 pi is a constant, so we can move that aside. The derivative of r cubed is 3r squared, and then chain rule, the derivative of r is dr over dt. Now, we solved for dr over dt at this moment, so we can plug that in, and we have all of the variables filled out to solve for the change in volume with respect to time, which is 21 pi. So as you can see, at this moment, the rate of change of the sphere's volume is 21 pi cubic meters per hour. I hope this video helped. Comment down below any other math topics you want me to review. Thank you.